All right, in this lesson we're going to talk about similar triangles. There's some unique things that we can do with triangles. All right, so when we're talking about similar triangles, just like we did with triangle congruency, we have some shortcuts that we can use. So there's a couple similarity postulates. There's not as many, there's 3 of them. So we've got, if all 3 sides are proportional, we can say the triangles are similar. If you have a side and an included angle and another side, the sides are proportional, the angles are congruent. And then 2 angles that are congruent, we can say that the shapes would be similar. Okay, we'll take a look at them in detail. So triangles are similar if all 3 sides of one triangle are proportionate to all 3 sides of another triangle. So here's a picture. We've got 6, 7, and 10. So well, that we've actually got a missing side on this one. So if we said the proportion from, we'll call this triangle A, we'll call this triangle B. Are they proportionate? Well, let's check it out. 6 to 12. Does that equal 7 to 14? And does that equal 10? Well, what would that have to be? Let's ask that question. Well, I know 6 over 12 is the same as 1/2. 7 over 14 is the same as 1/2. So 10 over what number would be 1/2? And that's going to be 10 over 20. So I know this side would need to be 20 for these 2 to be proportionate and similar by side, side, side. 3 sides that are proportionate. Okay, let's check these out. And again, you don't have to get too hung up on what matches what, because it needs to go smallest to largest, or largest to smallest, as long as they are going in that order. So 20, then 25, then 35. All right, well, I know that 10 over 20 is the same as 1/2. 15 over 25 is not 1/2, because I know 15 over 30 is 1/2. So right there, I don't have to keep checking because this is not proportionate. So I'm going to say no, because the sides are not proportional. Okay, let's check these out. I've got 10, 15, and 20. And that should equal 12, 18, and 24. These are pretty easy numbers to reduce. I could say 10 over 12 is 5 over 6. I could say this is 5 times 3. This is 6 times 3. So that is 5 over 6, reducing the 3's. I could say this is 5 times 4 is 20. 6 times 4 is 24. Reduce the 4's, and this becomes 5/6. So by reducing the fractions, I can tell that these are all proportional. If you didn't do that, then you would just divide 10 divided by 12 and you'd get a decimal. Compare that, 15 divided by 18, get a decimal. 20 divided by 24, get a decimal. And compare those decimals. Either way would have worked there. So this is a yes. All right, side and then the included angle. Triangles are similar if 2 pairs are the sides are proportionate and their included angle is congruent. All right, so we're looking at this angle is congruent to this angle, and that is between the 2 sides, 12 and 24. So I'm going to match up 12 and 24 to 8 and 16. All right, well, once again, I could reduce my fractions. 4 times 3 is 12. 4 times 2 is 8. That becomes 3/2. And let's see, 8 times 3 is 24. 8 times 2 is 16. 8's reduced, and that becomes 3/2. So I know based on that the sides are proportional. And once again, if I didn't feel comfortable reducing my fractions, then I can say 12 divided by 8 is 1.5. And 24 divided by 16 is also 1.5. And I could check it off that way. All right, side angle side. Well, we have an angle here and an angle here. The problem with this picture is these are side angle side. The angle is included between them. But here I would need to know this side, not this one. And I don't know that side, so I can't check this one. So this would be not enough info to check it by side angle side. All right, are these ones similar? Well, we have a congruent vertical angles here. So now I have to check is, let's see, we'll match up 18 and 24, matching 27 and 36. All right. So again, reducing fractions, I would get 9 times 2 and 9 times 3. Reduce that to 2/3. 6 times 4 is 24. 6 times 6 is 36. That would give us 4/6, but I could reduce that more. 4/6 reduces to 2 times 2 and 2 times 3. So that would be 2/3. So the 2/3 equaling 2/3. So this is a yes. Again, just divide and get decimals if you would like to do that instead. All right, now look at this picture. What you got to look at is this triangle here, and there's a separate triangle. Let me get a different color for you. Right here. Okay, so you got a little nested triangle and a bigger triangle. So what are we looking at? Well, they have a shared angle, so that's going to be congruent. And now I just need to compare, is 9 and 12 proportionate to this green side is 12 and this side here is 17. All right, those don't look like they're super easy to reduce, so let's go with 9 divided by 12 is 0.75, and 12 divided by 17 is 0.70. So these are not proportional. Not similar because the sides are not proportionate. Okay, same thing here. We got a little triangle. So, and they have a shared angle, so the angles are fine. We just need to compare 4 and 5 to this side, 16, and this side, 20. All right, these look pretty easy to reduce, so I'm going to say this is the same thing as 1 over 4. 4 times 4 is 16. And this one is the same as 1 over 4. So this checks out, 1/4 and 1/4. All right, another postulate. If we have two angles that are both congruent, then we can say the shapes are similar. All right, so as long as we see two congruency markers, we're good to go. All right, so let's check these out. We got 58, 58. That checks out. 66, 66. That checks out. So these two are similar by angle, angle. But what about this third one? Well, be careful here, because what is this missing angle? 66 and 62 is 128. 180 minus 128, that is 52. So this angle is 52 degrees. Okay, so it's still not. I thought maybe this missing one might be 58. So it is, the purple one is not similar to the other two. All right, let's check it out. Are these triangles similar by angle, angle? So we've got this one that matches. Let's check. We need to see if this angle could possibly be 48, and I think this one is probably going to be that case. So 180 minus 102 gives me 78. Take away the other 30. That gives me 48. So this is actually 48 degrees, and that means this one is 30 degrees. So this is a yes. We just had to calculate the angles to find out for sure. So don't let that one trick you. All right, here we have vertical angles here and another angle that's marked. So this is a yes. All right, we got parallel lines. So we got vertical angles there. Parallel lines is going to give us alternate interior angles. And so this is a yes. All right, we've got a set of, let's see, 3, 4. These are good. These are good, but this is not congruent to either of these two. And so this is a no. All right, let's look at this one. It's kind of curious because we would have a shared angle here. So this triangle, right, it's got an angle congruent to, so let's redraw these real quick. So we'd have an angle congruent here. This angle is 73. This angle is 71. So in order to have two congruent angles, this one would have to be 71 and this one would have to be 73. Well, that's possible, but it's not necessarily the case. So there would be one case when that would be true. That would be 180 minus 73 and 71. That would be 144. Okay, so that would be 36. If this angle was 36 degrees, then those could be 73 and 71, and then it would be okay. However, we don't know that this angle is 36 degrees. So this is not enough information. Okay. And the last one, okay, now we have parallel line markers. That does some things for us. Again, we would have a shared angle here. And if these are parallel lines, this would be a transversal. And these would be corresponding angles. So these two would be congruent. And also these would be congruent. So you would have this one would work out with angle, angle. Okay. All right, that's it. And have a great day. Bye-bye.